In this session, I'm going to explain programming model of cloud computing. So that is fourth unit of cloud computing. So already we have discussed about 3 units, basics of cloud computing in the unit 1, and then virtualization concept in unit 3, and then this architecture model in the unit 3. Okay, so another one, programming model. So programming model in cloud computing, that is in fourth unit. Okay, in the fourth unit we are going to discuss about parallel and distributed programming paradigm, MapReduce, and twisted and iterative MapReduce, Hadoop library from Apache, mapping applications, programming support, Google App Engine, Amazon AWS, and the Microsoft Azure, cloud software environments like Eclipse, OpenNebula, OpenStack, Anaga. These are the concepts, programming model we are going to discuss in the cloud computing. In that, I am going to explain about Hadoop library from Apache. That's a Hadoop concepts. Okay, so Hadoop library from Apache. So Hadoop is an open source implementation of MapReduce, coded and released in Java by Apache. That's Hadoop is one of the open source implementations based on Java language. Okay, the Hadoop implementation of MapReduce uses the Hadoop distributed file systems (HDFS), and it is underlying layer than Google file systems. Okay, the Hadoop ecosystems. We'll explain the topics of Hadoop ecosystems. In the Hadoop ecosystem, we have some of the functionalities like Hadoop framework built by Apache Software Foundations inside includes Hadoop Common, and then Hadoop HDFS, and then Hadoop Yarn, and then Hadoop MapReduce, and then Hadoop Ocean. So these are the topics. These are the concepts in the Hadoop. Okay. So Hadoop Common is the common utilities and libraries that support the other Hadoop modules, also known as Hadoop core. It's nothing but common. Some utilities and the backend files will be support to the Hadoop. Okay. So another thing, Hadoop HDFS, the Hadoop distributed file systems. It's nothing but it provides the high throughput. We can access the data in the Hadoop HDFS distributed file systems very fast. Yeah, distributed file system for storing applications data on commodity hardware. It provides high throughput access to the data and high fault tolerance. The HDFS architecture features a name node to manage the file system namespace, and access the multiple data nodes to manage the data storage. In that, you are going to maintain the name node and data node, the master and slave concepts. Okay, so master is nothing but a name node, and the data node is nothing but a slave. So based on that, it perform the operations. So Hadoop distributed file systems, and then Hadoop Yarn. So Hadoop Yarn is nothing but a framework for managing cluster resources and scheduling jobs. There is nothing but it manage the clustering resources and also perform the scheduling operations, scheduling jobs. So Yarn stands for yet another resource negotiator. It supports more workloads and such as interactive SQL, advanced modeling, and real-time streaming. Okay, another thing, Hadoop MapReduce, a yarn-based system for parallel processing of large data sets. It's nothing but it is used to process the large amount of data sets based on the inputs. Okay, that's a MapReduce. And some Hadoop Ocean, a scalable, redundant, and distributed object store designed for big data applications. Based on the big data applications, so we can scale and redundant the data in the Hadoop. Okay, so these are the concepts in the Hadoop. Another one, the Hadoop core is divided into two fundamental layers. One is a MapReduce engine, another one is HDFS. Okay, so that's two layers. Perform the Hadoop is nothing but a distributed file systems. It store and process the large amount of data. That's a very huge amount of data will be stored in processed in the Hadoop. Okay, so HDFS is a distributed file systems inspired by Google file system that organizes files and stores their data under distributed computing systems. HDFS architecture. HDFS architecture is nothing but it's based on master and slave concepts. Okay, so say master and slave architecture containing a single name node as a master and containing a member of data nodes as a workers. To store file in the architecture, HDFS splits the file into fixed size blocks like example 64 MB. Each and every block will be as 64 MB and stores them on a worker node data nodes. Okay, so in that the mapping of blocks data nodes is determined by name nodes. So the name node also manages file systems metadata and namespace. In such systems, the namespace is the area maintaining the data, and metadata refers to all the information stored by a file system that is needed for overall management of all files. Okay, for example, name node in the data node stores all information regarding the locations of inputs, splits and blocks in all data nodes. Okay, this is about the HDFS concepts. So in the HDFS features is based on HDFS as a distributed file systems have special requirements such as performance, scalability, concurrency control, fault tolerance, and security requirements to operate efficiently. Hadoop considers the following issues to fulfill reliability requirements of the file systems. So block replications, replica placement, heartbeat, and block report messages. So and then HDFS operation also. Okay, so these are the following reliability requirements. Okay, block replication to that means to reliably store data in HDFS file blocks are replicated in these systems. That means it stored the server, large amount of data will be stored in many different servers. That's replicated among many different servers. Replica placements. The placement of replicas is another factor to fulfill the desired fault tolerance in HDFS. That means replica placement is nothing but data will be stored in many places. So that means it fulfill the concepts that is a fault tolerance. We have to reduce the tolerance. We have to reduce the fault in the systems. Okay, that's a fault replica placements. Heartbeat and block report messages. That is, heartbeats and block reports are periodic message sent to the name node by each data node in a cluster. Here we have a master and slave. So here master node so periodically send the message to the name node each and every seconds or every 1 milliseconds or every 1 minute it send the periodic message. What the process is going on, like that it send the messages. Okay, so that is a heartbeat and a block report messages. Another one, HDFS operations. The control flow of HDFS operations such as read and write operations can properly highlight roles of the name node and data nodes in the managing operations. To read a file in HDFS, the user sends an open request to the name node to get the location of the file blocks. Okay, if you want to perform the read, that means we are going to retrieve the data in the large file system. Means first you have to send the open request to the name node. Okay, so for each block, the name node returns the address of a set of data nodes containing replica information for the requested files. So that means the name node know the where the file will be located in the data nodes, like that it know the so data set of data nodes containing replica information about the requested files. So it only know the locations and then file number, like that it know. So based on that identify the retrieve the file and we can read the data in the particular files. The number of address depends on the number of blocks replicas. Based on the address, the number of blocks will be available. Based on that, address will be placed. That is n number of blocks. Okay, 3 blocks means 3 addresses, 4 blocks means 4 addresses, like that. Upon receiving such information, the user calls the read informations to connect those closest to data node containing the first block of the file. So based on that, it identifies the location. It connects the data sets and connect the closest to the data node from the name node and receive the information, retrieve the data in the nodes. Okay. So another thing is to write operation. So write operation means you have to going to store the data. That means you have to create the request to the name node to create a new file in the file system. If you want to store any data to the HDFS, means you are sending the write request to that's a create request to the name node. Okay, so no name node can identify the data node. That means whether the place is available in the data node, like that. Okay, if the file does not exist, the name node notifies the user and allows him to start writing data in the file by calling the write functions. With the help of if we are going to write the data. Okay, the data is not available. It does not exist means the name node allows the user to perform the write operations with the help of create request. So we can perform the write functions, that is to store the data in the particular data node. The first block of file written into an internal queues termed as a data queues, while a data streamer monitors its writing into a data node. Okay, so afterward the block is forwarded to the second data node by the first data node. Then after the once the one block is completely write the functions as write function means automatically forward to the next data nodes. So like that it perform the operations. So that's HDFS concepts. Okay, so So another thing is another concept is map reduce. So in that HDFS we already discussed about one is HDFS concepts. So another one is we have discussed about HDFS and also map reduce engine. That map reduce engine is nothing but it perform the mapping and reducing process. Okay, so map reduce is a distributed programming techniques proposed by a Google for a large scale data processing in distributed computing environments. So according to Jeffrey Dean and Sanjay Jamwat, the input for MapReduce computation is a list of pairs, that is a key and value of the particular data. Whereas, and each map functions produces 0 or more intermediate key value pairs by consuming one input key value pairs. The runtime groups the intermediate pairs based on some mechanisms like hashing into buckets representing reduced tasks like that. Okay, the reduced task take an intermediate key and a list of values as input and produce 0 or more output results. That's a map reduce functions. We will explain. We have a diagram that's explained. Here, the map reduce functions will be explained very clearly. The overall map reduce word count process. So input here we have input stage and then splitting and then mapping, shuffling, reducing and then final results. Here we have word count problem. That means here we have deer, beer, river, car, river, and then deer. Car beer. These are the words in the inputs. Here these the inputs will be split into three set of inputs. One is deer, beer, river, car, river, and then deer, car, river. So after that it will perform the mapping. So key value pairs based on deer how many times appear in this inputs, only one time, deer 1 and then beer 1 and then river 1, and then here also car 1, here car 1, river 1. So and then key value pass we are assigning the mapping the key values for the deer is 1, beer is 1 and the river is 1 like that, and then deer 1, car 1, beer like that perform the mapping option. And then here we have the many mapping values. Okay, so you have to shuffle. Okay, here where the beer is available based on the key value pair with shuffling. So beer 1 here and another beer is available in here. So here we have beer 1 and beer 1, and then here three input values, car 1 and here car 1. So car 1 and then deer 1. So deer 1 here also deer 1. So it will be shuffling, and then another river 1 here and another one river 1 here. So it's shuffled. Okay, so another one is perform the reducing operation. Here beer 2 times. Okay, beer comma key value pair is 2. So beer comma 2 and then car comma 3 and then deer comma 2 and then river comma 2. Like so finally we can get the results. So word count problem. So beer 2, car 3, deer 3 and then river 2. So we can easily identify the word count process. Here the input deer, beer, river, car, river and then deer, car, beer. So here beer will be 2 times and then car will be 3 times and then deer words will be 2 times and then river word will be 2 times. That is a map reduce concepts. Okay, so given that's a word count problem, so we can, this is a small input, we want to process the large amount means the map reduce process very helpful to find out the mapping and reducing process. So and finally we can get the final results so based on the mapping and reducing process. Okay. Okay, so that's all about HDFS, HDFS and then map reduce concepts. Okay, thank you.